The word Superfighter describes an outstanding warplane. It was first applied to the leading fighters of the late 1970s and 1980s. Their basic designs are already 30 years old, but constant upgrades will keep many of these in use well into the 21st century. The new generation of combat aircraft is now coming into service. These aircraft introduce new technologies, bringing whole new levels of fighting capability, in some cases, revolutionary ones. These new Superfighters will form the cornerstone of world air power for years to come. Many of these fighters were born during the free-spending years of the late Cold War. Defence budgets have been slashed since the end of that conflict, and air forces can afford fewer aircraft to carry out a wide range of missions. Any new types would have to be exceptional for a start. A single Superfighter may carry out tasks that would previously have taken as many as 6 other types of combat aircraft. They must now have so-called swing roll ability. The ability within the same mission to excel at both air-to-air and air-to-ground combat. This versatility comes from a combination of airframe, weapons and sensors. Incredibly strong, cunningly designed airframes make the new Superfighters stunningly agile. Stealth, previously applied only to attack aircraft, has a further revolutionizing effect. Their fantastic agility also comes from extremely powerful new engines with thrust vectoring nozzles. The ability to super cruise, to sustain supersonic flight without using afterburn, brings important tactical advantages. And critically, missiles can be given greater energy on launch, reaching more distant parts. These features mean that new Superfighters will outfly and outfight their rivals well into the future. And they're being armed with the very latest smart weapons. New short-range air-to-air missiles, such as the international ASRAAM and American A9X, are far more agile than the current Sidewinder. For engagements beyond visual range, the American ASRAAM will be armed with high-speed yet manoeuvrable missiles such as the European Meteor. For air-to-ground missions, the bulk of attack weapons are precision-guided. Superfighters carry the most avant-garde laser-steered bombs, as well as smart bombs controlled by GPS. And for standoff attack, munitions dispensers and cruise missiles are being used. But it's in the realm of sensors that Superfighters are really showing the way forward. Equipped with electronically scanned radars that bring new levels of performance and reliability. Most have an integrated defensive electronics system. These prioritize and assess all threats, then automatically launch counter-missions. Uptronic systems allow passive detection and targets tracking. Then the data is sorted, analysed and fused before being presented to the pilot. This means he can spend most of his time managing the tactical battle instead of monitoring the systems. In other words, fighting and not flying. These technologies are expensive, but the new Superfighters operate with greater efficiency than their forebears. All have the built-in ability to be upgraded well into the future. By any yardstick, Lockheed Martin's F-16 has been the most successful combat aircraft of the last 20 years. It's the world's most prolific fighter. Over 2,000 serve with the US Air Force. Another 2,000 are used in 19 other countries. Since its introduction in 1979, the F-16 has set the standards against which other fighters are judged. For example, along with its heavier counterpart, the F-15 Eagle, it was the first warplane able to withstand higher G-forces than the pilots. This means outstanding agility. The F-16 has evolved from a fairly simple day fighter into a complex multi-role aircraft. In late 1991, General Dynamics started producing its latest version, the Block 50-52 F-16CD. Key improvements included a cockpit compatible with night vision goggles, and the facility to fire the HARM anti-radar missile. The USAF has around 300 Block 50-52 F-16s. Around 100 of these have an important defence suppression role and are equipped with the HARM targeting system pod. Current orders mean that Lockheed Martin's production of this line will be busy until at least 2009. Many operators, including the United States Air Force, are upgrading their warplanes for continued service. Key new features include improved radar, helmet-mounted acuity systems, and targeting pods that will allow delivery of smart weapons. Even though more advanced designs are being developed, the F-16 will remain the cornerstone of world air power for the foreseeable future. The Mirage 2000 is France's most important combat aircraft, and versions have been specifically designed for key roles. The single-seat 2000C and the two-seat 2000B serve as its air defence fighters. The 2000N two-seater can carry out all-weather nuclear strikes at low altitude and at very high speed. The two-seat 2000D is another version without the conventional attack missions. The introduction of new weapons and systems in the 1990s has led to the new, more advanced Mirage 2005. Its RD wire radar makes it compatible with an important new air-to-air weapon, the Mecha. Mecha was developed to replace two previous missiles for both short and beyond visual range engagements. Thrust vectoring nozzles make it extremely agile and deadly. The missile is available in two versions, infrared and radar-guided. The Mirage 2005 entered service with the Armée de l'Air in 1998 and has since been exported to Taiwan, Qatar and Greece. Greece's order will comprise 15 Mirage 2005 Mark II aircraft. A multi-role version that is immense precision attack power, plus upgrades of older Mirage 2000s to the same standards. The United Arab Emirates has ordered 30 related aircraft known as the 2009s. While designs are constantly being developed, radically upgraded versions of several key fighters will soon enter service. Since the first flight of the prototype in 1995, Japan's Aero Self-Defense Force is now evaluating the operation of the Mitsubishi F2 support fighter. The F-16C was the starting point for the design of this fighter, but the Japanese have made new strides in its development. Compared to a standard Block 50 F-16, it features a high-tech wing, an integrated EW system, and active phased array radar among its important changes, all developed in Japan. The wing is 25% bigger and has a co-cured, all-composite construction. But these changes come at a high price. One F2 costs at least the same as 4 Block 50 F-16Cs. Despite these costs, the Japan Defense Agency has announced that it will buy 130 of these warplanes, an order of 83 single-seat F-2As and 47 two-seat F-2Bs. This program clearly illustrates Japan's commitment to its high-technology aerospace industry. The United Arab Emirates will receive the heavily revised Block 60-62 F-16 Desert Falcon within a similar delivery time. The upgraded Boeing F-18 Hornet will remain the US Navy's primary combat aircraft well into the 21st century. They received the first operational examples of the Super Hornet in 1999. Compared to earlier versions, it's about 25% larger. The airframe has been stretched and the radar cross-section reduced. A larger wing allows it to carry more weapons. And the Raytheon APG-73 radar has been upgraded. This is the same one fitted into later versions of the FA-18C and D. These also have more powerful engines and an enhanced defensive electronic countermeasures system. These changes mean that compared to earlier F-18s, the Super Hornet can fly further with heavier payloads and is more likely to survive the mission. The US Navy currently has a total requirement of at least 545 of them. Post-Desert Storm combat analysis showed the pilot's workload during combat was too high, and that the two-seat version worked better. In light of this, the majority of the US Navy's Super Hornets will be the two-seat F-18F. The rest will be single-seat E models. US Navy fighter and attack squadrons are now being steadily re-equipped with Super Hornets. The first full-rate production aircraft was delivered in September 2001. In July 2002, on board the supercarrier Abraham Lincoln, these fighters were deployed for the first time. In 2003, they saw combat during Operation Iraqi Freedom. F-14 VF fighter squadrons are fast becoming multi-role VFA units. Soon, all US Navy supercarriers will only use them as their principal combat aircraft. In the meantime, Hornets will also undertake a range of other combat roles with new equipment. This will include reconnaissance pods and active electronically scanned radar. This Superfighter is also being actively proposed for the defence suppression role. The Russian flanker has established a fearsome reputation for its exceptional aerodynamic performance and superb handling characteristics. For a basic heavy air defence fighter, Sukhoi has developed an astonishing number of variations to accomplish a wide range of roles. The single-seat Su-27M and related Su-35 and Su-37 models has a greatly improved dogfighting capability. New features include canards, thrust vectoring nozzles and an advanced cockpit. It is exceptionally agile, especially at high attack angles and in the post-stall area of the envelope. The two-seat Su-30MK has a greatly expanded air-to-ground capability. It has some of the features developed for the Su-27M, as well as advanced cockpit avionics and precision attack weapons. But all this has attracted scant interest from domestic and foreign operators. Development has stalled due to lack of funding. The Russian Superfighters face an uncertain future and competition from much more progressive Western rivals. But the baseline Su-27 continues to form the backbone of the Russian Air Forces, with some 400 of them in service. The Su-30MK has been exported to India and China. Delays have meant that their subvariants received all the features that were originally proposed later than expected. Despite these problems, the flanker still represents a formidable threat. While the US and Russia pursue their new superfighters for the 21st century, Europe has been developing three contemporary designs that share remarkably similar features. These are the Swedish Gripen, the French Rafale, and the multinational Typhoon. All have a canard four-plane delta configuration that produces an intentionally unstable aerodynamic. This is because the layout brings the benefits of low drag and enhanced lift. Most importantly, it makes the aircraft highly agile, particularly at supersonic speeds. All three types have entered operational service and are actively competing for export orders. First to fly and first to enter widespread service was the JAS-39 Gripen, or Griffon. It was designed to replace the older Vegan. The Gripen, although smaller than its other European counterparts, shares a similar delta canard configuration, coupled with a digital fly-by-wire control system. The single-engined Gripen is powered by a version of the F404J turbofare, the same as the Hornet. The modified engine features an outstanding thrust-to-weight ratio and high manoeuvrability. The Gripen prototype first flew in 1988 and entered service in 1997. To date, the Swedish Air Force has a total of 204 Gripens on order, 176 single-seaters and 28 fully combat-capable two-seaters. The third production batch of single-seaters will be to JAS-39C standard, the same as the Gripen offered for export. Features include improved human-machine interface, HMI, helmet-mounted sights, and infrared search and track system, as well as improved electronic warfare systems and in-flight refueling capability. These Gripens will be fully interoperable within NATO in terms of navigation, communications, weapon systems and support. The first export order was of 28 Gripens for South Africa. Hungary was the second, and signed an agreement to lease 12 Gripen single-seaters and 2 single-seater aircraft, the JAS-39D, in 2001. While upgraded versions of the Mirage 2000 remain in constant use with the French Air Force, the French naval air arm, the Aéronaval, has recently received some of France's next innovative warplanes. The Dassault Rafale. It will replace as many as 8 of the existing types currently in service with the French Air Force and Aéronaval. The development suffered from defence cuts caused by the end of the Cold War, but the programme is now back on track. Rafale represents the jewel in the French aerospace industry. The aircraft introduces a range of formidable technical advances, all of which have been developed by French companies. Like the other Superfighters, Rafale is designed to bring warfighting up to a new level. This is thanks to the fusion of data from the aircraft sensors, radar, optronics and countermeasures. The data is sorted and presented to the pilot in such a way that he can concentrate on managing the tactical battle, rather than on monitoring systems. The Rafale's RBE-2 multi-mode phased array radar is the first in Europe, with 2-plane electronic scanning. The radar can pick up to 8 targets simultaneously, and provides threat identification and is able to prioritise them. The pilot is equipped with an advanced helmet that has sight and display. USAF is a jam-resistant passive optronic surveillance and imaging system with laser rangefinder. The optronics suite carries out search, target identification, telemetry and automatic target discrimination and tracking, all without emitting telltale signs. The smart electronic warfare system called Spectra can automatically detect hostile radars or missiles and launch decoys and other countermeasures. The Aéronaval's pressing need to replace its veteran F-8 Crusaders meant that it has become the first service to operate Rafale. The service is requiring 60 navalised fighters in a mix of single-seat Rafale M's and 2-seat Rafale N's. These will operate from the new carrier, Charles de Gaulle. The Armée de l'Air is now receiving limited numbers of its first Rafales. It plans to buy around 230 of them, the majority of which will be the 2-seat Rafale B. These will be in several progressive standards. F1, optimised for the air-to-air role, F2, with improved air-to-surface capability, and the definitive Rafale F3, with improved radar and engines. Called Operation Global Punch, this plan has been put together recently as part of Dassault's marketing efforts to sell the Rafale. It illustrates the multi-role competency of the 2 primary combat versions, the naval single-seat Rafale M and the Air Force's 2-seat Rafale B.
Okay, we're clear to go. Weapons ready. In range. Shoot. Shoot. On the way. Sam! Right. Jimmy, let's take off.
It has now become prohibitively expensive for individual nations to pursue their own national fighter programs. Gripen and Rafale almost certainly will be the two last major combat aircraft to be developed by a single European nation. The path pursued by the biggest of the European trio, the Eurofighter Typhoon, is a multinational collaboration. Eurofighter is being jointly developed and produced by Germany, Italy, the UK and Spain. The Typhoon is designed as a multi-role combat aircraft. It's mostly for air combat beyond visual ranges, but also has an important secondary ground attack capability. This international consortia have been formed to develop the airframe, engine, multi-mode radar, IRST, and a highly advanced smart electronic warfare suite. Eurofighter has an extremely complex cockpit that even includes direct voice command, so the pilot can carry out a selection of radar modes and data entry procedures using speech. The flying program got underway in 1994, with the first flights of 2 of the 8 planned prototypes. In 1998, Eurofighter 2000 received the name Typhoon. The first production aircraft was rolled out in the second half of 2001 and began to come into use in 2003. In terms of sheer numbers, Eurofighter is by far Europe's most important combat aircraft program. It's anticipated that at least 800 will be built. The respective national requirements were finally settled on in 2000 as a maximum of 297 for the UK, 180 for Germany, 130 for Italy, and 103 for Spain. In addition, an export order of 60 Typhoons for Greece was signed in 1999. Other exports are likely. One manufacturer, Lockheed Martin, has cornered the lion's share of the 2 critical Superfighter programs that will form the core of the US Air Force's warfighting power over the coming decades. The United States Air Force needs an F-15 replacement, and the F-22 Raptor is being developed to meet this need for an advanced tactical fighter. As far as is known, stealth has previously been only applied to attack aircraft, such as the F-117 Nighthawk and the B-2 Spirit. The F-22 is the world's first stealthy fighter. It will revolutionize air combat in the same way that the F-117 and B-2 changed the face of attack warfare. Key features include the trapezoidal wing, whose angles are repeated on the other surfaces to reduce radar signature, dented fins, and internal weapons carriage. In terms of materials, most of the Raptor's wings, 39%, is made up of titanium. Composites account for 24%, and aluminium, a traditional aerospace material, makes up only 16%. The F-22 is run by 2 F-19 engines, which have a high military power rating, allowing it to supercruise over long ranges. This superfighter has been designed to restore the United States Air Force's technological advantage over its rivals. It is intended to outfly and outfight all others. When it enters service, it will be by far the world's most advanced combat aircraft. Artificial intelligence algorithms fuse data from the sensors and present only relevant information to the pilot. These reduce his workload, while at the same time improve tactical awareness. For missions where stealth is a key requirement, the Raptor will carry all its weapons internally in 3 weapons bays. After a lengthy phase of engineering, manufacturing and development, the Raptor came into use in 2006. Experience gained on the F-22 is being applied directly to the Joint Strike Fighter, or JSF, project. This is potentially the biggest military aircraft program in history. The US services alone may possibly require as many as 3,000 of them to replace key types such as the F-16, FA-18, A-10 and AV-8B. And then there are further prospects for massive export orders. The JSF revolutionises aircraft development. It's not that much faster or more manoeuvrable than the current F-16, but what it does bring is affordable stealth capability. As such, it is designed to a certain price, and capabilities are traded off against each other to meet that price. 3 basic JSF variants are being developed. All will have 70 to 90% common parts, including canopy and most of the avionics. The F-35A is the conventional takeoff and landing version. The United States Air Force needs as many as 1,800 of them as air-to-ground strike aircraft to replace F-16s and A-10s. It will complement F-22 in the so-called high-low mix. The F-25B is being developed for the US Marine Corps, the Royal Air Force and the Royal Navy. It will become the world's first operational supersonic aircraft, the STOVL, that is, short takeoff and vertical landing. The STOVL system uses an advanced shaft-driven lift-fan propulsion system. Developed by Rolls-Royce Defence, a lift fan behind the cockpit provides around half the thrust required for hovering flight. The lift fan takes up valuable space. On other versions, this space is reserved for fuel. Nevertheless, the Marine Corps feel that the trade-off in range is worthwhile, as this fighter will be used in a close air support role. The service will potentially need as many as 500 of them to replace its Hornets and Harriers in the CAS and strike roles. The F-35C is the carrier-based JSF version for the US Navy. A larger new wing incorporates leading-edge flaps and foldable wingtip sections. Coupled with larger tail control surfaces, this gives improved piloting during carrier landings. The US Navy potentially requires about 500 of these to replace first-generation FA-18 Hornets and complement the Super Hornet. It will be the service's only stealthy flight platform and is designed to be most effective for first-day stealth. The JSF, the F-22 Raptor and the new European Superfighters represent the pinnacle of combat aircraft development. Excluding research and development and weapons, a single F-22 currently costs around $120 million. swing-roll Superfighters will have an increasingly tough time operating in a dense electronic warfare environment in the ever-growing threat posed by battlefield air defence systems. Even as this generation of Superfighters is entering air forces, designers are looking at the next genesis of combat aircraft. One type, built and tested in the mid-1990s, seems to come from the realm of science fiction: the bird of prey. The US Air Forces and Boeing unveiled this previously ultra-secret prototype in October 2002. Named after the Romulan bird of prey from the Star Trek series, this fighter and tactical bomber was designed to be stealthy enough to survive in broad daylight. The bird of prey has been retired, but its innovative features are influencing the future design of all stealth aircraft. The prime example is Boeing's X-45 Unmanned Combat Air Vehicle, or UCAF, prototype. The UCAF will demonstrate the technical feasibility for an unmanned combat aircraft to conduct a range of missions, including defence suppression and strikes. The UCAF represents one possible vision, however. The current Superfighters are very much here to stay for the foreseeable future. The next 5 to 10 years will be very interesting, as each of these Superfighters is presented with its own window of opportunity for sales. Competition for orders will continue to be fierce. The capabilities of these Superfighters are stunning. Any Air Force purchasing them will gain a quantum leap in fighting power.